Hey guys, welcome back everybody. So today we're going to talk about how to configure the OSPF multi-area. Now the question is that why do we need a multi-area if you have already single area? Right? So simple reason is that because there is a limitation, you cannot put all the routers in a single area. Like as per the Cisco documentation, it's saying that you can put the 50 to 60 routers in the single area. Right? If you have a beyond that, better to create the multiple areas over there. Now, basically in the OSPF, what happened? The areas is a 32-bit size that you can define in the dotted decimal format and decimal format as well. Now, if I talk about why do we need a multi-area configuration, so there's a major four reasons is that what? The first of all, if you can do the multi-area configuration, it's gonna simplify your network, right? That's our first example we have. Second thing, if I talk about if you're going to do the multi-area configuration, in that case, what happened? Your load will be reduced on the router side, right? So previously, let's say example, you have a router number 1, router number 2, and router number 3 right now. What happened if they have a part of the same area, area number 0? All the database information will be identical on every router, right? But what happened if I'm gonna reduce the routers in the area? So if I'm gonna put this guy, router 1 and router 2 is a part of the area 0, and router 2 and router 3 is a part of the area number 1. In that case, what happened? Your database table size will be reduced now. So R3 is not gonna maintain the detailed information about the R1. So you can see the lot of CPU, weight, and you can see the lot of memory as well. These are the three major reasons. The next one that we have over here is what? If the multi-area configuration we have, right, in that case, what happened? It's become a easy to troubleshoot over here. How it's become a easy to troubleshoot? Because you have a less amount of database table size. So it's become a easy to troubleshoot over here. These are the major four reasons why you're gonna prefer the multi-area configuration in OSPF protocol. Now, if you see this topology right now, I do have a area 100 right now. As I mentioned, that area is a 32-bit number, right? In this 32-bit number, what happened? You can define the area in the two format. Either you can go in the dotted decimal format, right? And either you can go with the decimal format, right? So dotted decimal format in the sense of, let's example, you can define the area. Let's example, we have area 0. So you can define the area 0 or 0 or 0 or 0 or 0. That's on this one. So if I talk about the standard one, what you following in the production network, you are just following this one, decimal format. It's easy to configure it or easy to remember it as well. Now in this 32-bit area, what happened? A lot of areas it's reserved as well. For example, not a lot of area 0 is only reserved, area 0 which is reserved for the backbone area, right? So why we call this guy the backbone area? Because without area 0 you cannot provide the inter area communication. So if you see that we have area number 100 over here and we have area number 200 over here. If I want to achieve the communication between router 1 and router 8 right now, right, I need a area 0. That's why I put the area 0 in middle right now. So area 0 is called the backbone area. Without area 0, inter-area communication is not possible. Now, apart from the backbone area, we do have different types of area as well. Like stub area, we have totally stub area, we have NSA, totally NSA. We'll talk about separately in the different videos. But let's focus on the multi-area configuration on the IOS XR router. So what we can do that the step number 1 we have, first of all, we'll configure the IP addressing. So I'll use my notepad. Okay, I'll use my notepad over here to configure the router 1. That's XR1 basically, right? On the XR1 we have a config terminal hosting will be router 1 and interface 0/0/0/0/10.12.1/24. No shutdown interface loopback number 1. So my goal is our achieve the end-to-end communication between router 1 and router 8. And then we have interface gig 0y0y1. IP address will be 10.113.1/24 as well, no shutdown. Same thing on the router number 2 as well. Right, on a router number 2 we have a 2.2.2.2/32, and this guy should be go with the 12.2, and the gig 0y1 should be go with the 24.2. Right, now we have router 3 as well. On router 3 we have a this is router 3, we gig 0x0 is a 13.3, and this should be go with the 3.3.3.3.3/32, and this should be go with the 35.3 as well. So R3 and R5 we have a 35.0/24 network. Now we have router 4 as well. On router 4 we have this guy. So between the router 4 and router 2 we have a 24.0/24. So this guy will go with the 24.4, and the loopback we have a 4.4.4.4/32, and the gig 0/1 we have a 45.4. Now router 5, now if I talk about router 5, you can see that this one. So router 5 and router 3 is running with the 35. So I'll call this guy the 35. Okay, and this loopback will be 5555. And then finally we have router 5 and router 6 right now, 56.5. Now then we have router 6 right now. Router 6 we have this interface, or with 3 interface we have over here. So router 6, then we have a gig 0/0, we have a 46.6, sorry, this should be the 46. And then we have a, I think so I have configured the R4 is correctly, right? This should be the 46.4. That's good. On the loop back I have 6.6.6.6/32, and then we have a gig 0/1. It should be go with the 56.6 as well. At the same time we have interface gig 0/0/2. That's IP address will be 10.167.6/24. No shutdown. So router 6 also done now. We have to configure the router 7. Let's move this notepad over here. In router 7, if you see, we have a config terminal. This part is seen. I'll copy and paste it over here as well. So 0/0 will be 67.7. Loopback will be 7.7.7. And then we have a 0/1 will be 78.7 as well. Then we have router number 8 right now. On the router 8 we have a single interface, so I'll manually configure it. R8 interface gig 0/0/0. IP address will be 10.178.8/24. No shutdown. Interface loopback number 1. IP address will be 8.8.8/32, and commit this guy. Oh, I haven't commit anyway, right? So let me commit it on every router. Commit. I'll get the host name will be router 7. Then we have a commit this guy, and then we have a router 6 is good. Then we need to commit this R5 as well, and then we have a, this is my router 5, right? And then we have a commit this guy. Then we have router 4 as well. How about this one? Commit. This should be the router number 3. Commit this guy, and this will be go with the router number 2. And all good. So we have configured the IP addressing. That's my step number 1, right? Step number 2, what we can do that? We need to configure the routing protocol as well. So I'll go to the router number 1, step 2, configure OSPF, right? On the router number 1, in the last video we have seen how to configure the OSPF protocol on the XR router, right? So if you have no idea how to configure the OSPF on the XR, I suggest you to please watch the videos of single area where I have explained that what is the difference of the configuration between the IOS and IOS XR. So we have router OSPF 1. We need to go to the areas 200 right now. This is the router 1, and we need to call the interface over there. Interface gig 0/0/0. I'll give the exit keyword as well, but you know I'm used to of this thing. I'll better to give the 1 and the loopback as well. Same thing on the router number 2. I'll commit this guy on router number 2 as well. On these router that you see right now, right, on this router I'm not gonna advertise my loopback. I do have a loopback on every router as per the router 9, but I'm not gonna advertise this loopback IP address. I'm only gonna advertise the loopback of router 1 and router number 8 so that we can ping to the end-to-end. Right, so all good. I'll go router number 2 right now. Router OSPF 1, area number 100, and interface gig 0/0/0, interface gig 0/0/1. Commit this guy on R3 as well. I have a similar configuration and copy and paste it. On a router 4 we have router 4. Okay, my bad. This should be to close it like this way over here, and this would be over here. All good? Yeah, that's good now. So router number 2, this router, and router number 3, right? It should be participating into the two different areas. So this interface exit from here, area 0, right? That is participating into the area 0. And same way on the router 3, this interface is a part of the area 100, this interface is a part of the area 0. So I'll say the exit from here, area 0, and that's good. On router 4 as well, router 4 we have a router OSPF number 1, area number 0, interface gig 0 by 0 by 0, interface gig 0 by 0 by 1. Same way on the router 5 as well, I'll come with this guy. Router 5 as well, we have a router OSPF, and we'll come with this one. So router 5 also have two interfaces, the part of the area 0. Router 6, if I talk about, on router 6 we have a router OSPF number 1. These two interface part of the area 0, which is the gig 0 by 0 by 0 and the gig 0 by 0 by 1. Now the area number 200 has this interface, gig 2. Interface gig 2. Same thing on the router 7 right now. On router 7 we have router OSPF number 1, area number 200, interface I have gig 0 by 0 by 0 and interface gig 0 by 0 by 1. And finally we have router 8, which is this router that has our one loop back, config terminal router OSPF number 1, area number 200, and we have our interface gig 0 by 0 by 0. That's good, and loop back. Commit this guy. And also we need to commit this one as well. And router 6. So if you see that, I finally configured my OSPF routing protocol. So if you have a look in this topology right now, right, this is the router, right, this interface is the part of the area number 100, and this interface is part of the area number 0. Same way, this interface is part of the area number 100, and this interface is part of the area 0. Same way, router 6, this interface is part of the area number 200, and this 2 interface is part of the area 0. So it means that this router will behave like a ABR, area border router, a router who provide the connectivity between the two different areas. It's a border router, right? So let's example, right, whenever your router, whenever the router of the interface at least belong to the one of the whenever the router is going to provide the connectivity between the two different area, and at least one of the interface of that router belongs to the area 0, that router is called as an ABR router. Understand this example right now. We have router number 1 and router number 2 right now, and router 3. And let's example, we have 0 by 0 and 0 by 1 right now, right? And this is the 0 by 0 and this is the 0 by 0. And it's my 12.1 and the 12.2 right now. This is 23.2 and 23.3, right? What happened if I'm going to make this guy as a part of the area number 1, and if I'm going to make this guy as part of the area number 2 right now, do you know what happened in that case? Router 2 cannot participate into the ABR because it is not satisfying the criteria of the ABR, because they don't have any backbone area interface. What I can do that, if I'm going to get the one loop back over here, maybe the loop back 2.2.2.2, and if I'm going to make this loop back as a part of the area 0, automatically what happened, router 2 can become the ABR, and once this guy will become the ABR, the communication will happen between the router 1 and router 3 as well. So at least one interface should belong to the area 0, no matter which interface. Either you have logical and physical, that's perfectly fine. But if the interface is not participating into the area 0, it cannot take a role of the ABR. So same way, if you see, this router and this router has a one interface part of the area 0. Same way, this interface is the part of the area 0. At the same time, this interface part of the area 200 and this interface part of the area number 100. At the same time, this interface as well. So these three routers are participating into the ABR right now. So let's configure it. So I'll go to the XR number 1. I'll give the username Law Cisco 1 password, Cisco 1 password, Law Cisco 1. I'll configure the IP addressing. Copy. I have a router number 2 as well. Cisco 1, Cisco 1, Law Cisco 1. And router 3 as well. Law Cisco 1, Cisco 1, right? Law Cisco 1. And here we go, commit this guy. We are out of 4 as well. Law Cisco 1, Cisco 1, Law Cisco 1, and commit this guy. All good. Now we have a router 5 as well. Law Cisco 1, Cisco 1. R6. R6 is the another AVR router. So we have router 6 right now, Law Cisco 1, Cisco 1. Commit this guy, and here we go. Router 7 right now. Law Cisco 1 and Cisco 1, Cisco 1, Cisco 1. All done, and then we have router number 8 as well. So in production, what happened, right? You do encounter the single area and the multi-area as well. It's totally depend on the configuration perspective. Configuration and the requirement, I'm so sorry. So I personally have seen the single area as well. So normally I'll tell you, so whenever you have a DMVPN setup, right, people are used to configuring the single area if you have a small, hub and spoke scenario. And but in service provider network, what happened, every time you do encounter the multi-area. So IP address has been configured, right? And now let's configure the OSPF routing protocol on router number 1. Config terminal, I do it in R2 as well. R3 as well. R4 as well. R5. R6. And R7. And then finally we have R8. So only on the router number 1 and router number 8 we advertise the loopback IP. So loopback we are treating like right now over here as a endpoint. OSPF, yeah, you need to wait for the good time, right? Wait time is a 40 second over here, which is called as a waiting time. So the BDR is getting elected right now. So meantime you can have a coffee as well, a small coffee. So now you can see on the router number 1, right? So IP OSPF interface brief. Okay, that's good. So OSPF, so IP root right now. It's getting it. Wait for some more time. Yep, 8 is getting right now, and I should be able to pay. source loopback remover. All good, right? So finally we have configured the OSPF multi-area configuration on the XR router. I don't want to make this video longer, so in the next video what we can do that we can make a verification on this particular routers, and we'll see that whatever the routers we have, a AVR, type 3 LSA and OIA route and some more commands as well. Thank you so much guys, see you in the next video.